All right, let's dive into one of the coolest frontiers in artificial intelligence right now, the mission to give machines senses. We're talking about AI that doesn't just crunch text or analyze a photo, but can actually see, hear, and understand all of it together, kind of like we do. This is going to be fun.
So, have you ever wondered about this? Your smart assistant can read you the weather forecast, no problem. It hears your voice, processes it, and gives you a text based answer. But if you were to show it a meme, which, let's be honest, is a complex mix of an image and text creating a totally new, often hilarious meaning, well, it would be completely clueless. So, what gives?
Well, the reason is actually pretty straightforward. Most of the AI systems we use today are specialists. They've been trained to do one thing really, really well. So you've got one model that's a genius with text, another that's a whiz with images, and a third that's an expert in audio. The problem is, they're all living in their own separate little worlds. They can't connect the dots between what they're seeing and what they're reading.
And that brings us to our first big idea, AI's missing senses. To fix this, researchers are on a quest to give machines a much more complete, much more human-like way of perceiving the world. And look, this isn't just about making AI a little bit smarter, it's about making it fundamentally more capable of understanding our complex, messy, and very, very multimodal world. The solution has a name. It's called multimodal learning. And the key idea here isn't just about feeding an AI different types of data at the same time. No, the real magic is teaching it to find the relationship between them. By combining the strengths of each sense, the AI can build a much richer, more detailed picture of reality. It's all about creating something that's way more powerful than just the sum of its parts. So how in the world does this actually work, right? How do you teach a bunch of code to connect the pixels in a photo with the letters in a sentence? Let's pull back the curtain and look at the mechanics of teaching AI to connect these new senses. Okay, it really boils down to three huge steps. First up, you have representation. The AI has to take all this raw stuff, like the millions of pixels in a picture or the complex sound waves of someone talking, and convert it into a numerical format it can actually work with. Next, you have alignment. This is where it gets really cool. The AI learns to map these different data types into a shared conceptual space. And finally, there's fusion. This is where the AI has to intelligently mix all this aligned info to come up with an actual answer or response. Just think about how you watch a movie. You effortlessly fuse the visuals, the dialogue, and the music to understand the story. AI has to learn to do that exact same thing. So the whole point of those first two steps, representation and alignment, is to create a kind of universal language inside the AI's brain. It needs to learn that the text string dog, a photograph of a golden retriever, and the sound of a bark are all pointing to the exact same idea. A really popular technique for this is called contrastive learning. You can think of it like a giant matching game for the AI. It gets shown a picture and the right caption and is told, see, these two go together. And at the same time, it's shown a picture with the wrong caption and told, nope, these two do not belong. Over and over, millions of times, until it starts to get it. And that brings us to our third section, the art of the mix. Because, once you have all this data aligned, you still have to combine it. And it turns out that how, and maybe more importantly, when you fuse all this information together, is one of the most critical choices you can make when you're building one of these models. There are really two main camps here. On one side, you've got early fusion. I love this analogy. It's like making a smoothie. You just throw everything, your image data, your text data, all of it, into the blender right at the beginning and hit go. It's simple, it's direct, and it works great when the data's already pretty similar. But on the other side, you've got late fusion. This is more like making a layered cocktail. You process each sense with its own special model first, getting the best out of each one, and then you combine the final result at the very end. You do this to protect all the unique little details from each data type before they all get mushed together. And of course, it's not just one or the other. There's also a middle ground, often called intermediate fusion. This approach lets the different data streams kind of interact and influence each other in layers, all throughout the learning process. It's a hybrid approach, and it's proving to be super powerful in really complex fields, like analyzing biomedical data, where all the signals are incredibly subtle. Okay, so that's the how. Now for the really important part, the so what. Let's shift gears from the theory in the lab to the real world and check out the amazing things this tech is already doing and also some of the really tough challenges that are still standing in the way. In healthcare, the potential is just staggering. A multimodal AI can look at a medical scan, say an X-ray, and automatically write a first draft of a report for a radiologist to review,
But even better, by fusing that visual data with a patient's medical history, it can help doctors spot patterns that a human might miss, leading to earlier and more accurate diagnoses. Actually, there's a good chance you've already played with this technology. Anytime you've used one of those text-to-image generators, you're using a multimodal AI. It's the thing that understands your wild text prompt and somehow translates it into a picture. It's also the magic behind automatic video captioning and what lets you search your phone's photo library by just typing something like beach sunset.
And for things like self-driving cars or robotics, this isn't just a neat feature, it's absolutely essential. A car has to take the data from its cameras, its LiDAR, its radar, and even its microphones, and fuse it all together into one single, coherent 360-degree picture of what's happening around it. This kind of robust perception is the absolute key to making these systems safe and reliable.
But look, it is not all smooth sailing. Researchers are still wrestling with some seriously difficult problems. For instance, what do you do when one of the sensors on your self-driving car fails and you suddenly have missing data? How do you keep training these enormous models when it costs a fortune in computing power? And a really big one, how do you make them tough enough to handle random noise or even deliberate malicious attacks? Without solid answers and without standard ways to even measure progress fairly, it's really hard to bring this tech into high-stakes, real-world situations.
So, where does all of this leave us? What's the next chapter for an AI that's starting to see, hear, and perceive the world in a way that looks, well, a lot more like how we do it?
I think this quote from one of the core research papers just nails it perfectly. The ultimate goal here, the big dream, isn't just about building a better image generator or a slightly smarter assistant. It's about building an AI that can see, listen, read, and reason about the world all at once, tackling complex jobs with the kind of flexible, context-aware intelligence that up until now has really only belonged to us. And that really leaves us with one last huge question to think about. We're seeing AI move from just processing data to actually perceiving the world. So what happens when it finally starts to understand our world with all of its nuance, context, and complexity as deeply as we do? The possibilities are truly as revolutionary as they are profound. Thanks for joining us for this explainer.